We're going to be talking about how imaginary numbers affect the solutions in quadratic functions and the idea behind imaginary number. So first off, we're looking at exercise 1, which gives you a sketch of y equals x squared, and they give us a new function they call f of x equals x squared plus 1. So if we were shifting to get that f of x, basically we're going to shift every point one space up. So imagine me just kind of sketching in some of the points that I would see. I'm just kind of drawing it. Now, for C, it says, what about the X-intercepts? So there are no X-intercepts, because that graph doesn't touch the x-axis. So if we were going to solve this and see when it's set equal to 0, what we'd have to do is subtract 1 on each side, and then you have to take the square root of each side, so then x would equal the square root of -1. Now if you put that in the calculator, it's going to say non-real answer, which makes sense because there's no real answer that we saw. So what is done for that case of a negative square root, what they do is they give that the idea and the definition of the letter I, which is imaginary. So you'll see a lot of the rules apply to I that apply to x's when we're combining like terms. And we'll also talk about if I is negative, the square root of -1, well, I squared is going to equal that -1. So we'll talk about that as well. So we're going to simplify each of these square roots and put them in terms of I, and you'll notice that they're all negative. So what you can do for each one is you can factor out that negative. So if I factor out -9 into -1 times 9, that means I'm going to have 3 for the radical 9, and then I for the radical for -1. And same thing with B. We got -1 times 100, and radical 100 is 10, and then this would be I. And you can have to simplify them like we talked about before, where you have a radical left over. Well, this one right here would be -1 times radical 32. And 32 is not a perfect square, but that one will break up into 16 and 2. So we'd end up with 4 for the 16, I for the -1, and then the radical left over, which will go at the end. So for each of these, you want to factor out that -1 first, kind of like I did here, here, and here, and then see if you can factor or see if those will simplify any farther. Now we're going to look at one of the examples for exercise 3. I'm going to move this up just a little bit. We're going to take a look at C. So what I'm going to do right here is I'm going to go ahead and just try to get that x squared by itself. So I'm going to add 10 to each side. And then you have 2x squared equals -26. And I'm going to divide each side by 2 to get x squared is -13. And again, what I'm doing is I'm doing those orders of operations in reverse. Now I'm going to take the square root of the x squared, and that means I'm taking a square root of a negative value. So that means that x is going to equal, in this case, it could be two possibilities. There's a plus and a minus, and the I is going to be factored out, and then we have the radical 13. So we have two possible imaginary roots. There's positive I radical 13 and negative I radical 13. And you'll kind of see that with some of the other ones as well. If you look at, let's say, A, this one will work out to be a whole number with I. So if I subtract 8 on both sides, I'll get 5x squared equals -20. Divide by 5, and I get x squared equals -4. Take the radical, I'll get x equals plus or minus and then that negative 4 will be negative 1 times 4, which will end up being 2i. So you have two imaginary roots, 2i and negative 2i. Now moving on to some of the other exercises, you can do operations with the value I, just like you would with numbers or variables. Same rules apply. So if you take this equation here, they want to know what's equivalent to this, 5i times 6i. Well, that's going to be 30i squared. Now, I squared equals the number negative 1. So this is just 30 times negative 1, which end up being choice 3. So the idea with the powers of I, because you could have exponents, is being able to relate them to certain values that we would come across, because it's a cycle, just like some other values that we'd see in math. Now, if you move on to exercises 5, 6, and 7, they show you here first that I to the first power is just I. But we just talked about I to the second power, which that would be negative 1. And I to the third would be negative I. So the idea with that is that I to the third would be the same as I to the first times I to the second. And I to the first is I, and I squared is negative 1. So if you did negative 1 times I, you'd get negative I. Just like if you did negative 1 times x, you get negative 1x. And then if we do I to the fourth, that's actually just going to be the number 1. Because if you take two of the powers for any of the ones before, if you take I squared twice, that's negative 1 times negative 1. Now there's a pattern with this, and what happens is those same four values end up repeating over and over. So if you do 9th, 10th, 11th, and 12th, you're going to get I, negative 1, negative I, and 1. So if you're thinking about which one it will be for these higher ones in exercise 6, so if I take, let's say, this one, C, I to the 83rd power. So what I want to think about is this. Each of these, 1, 2, 3, and 4, there's a 4-term cycle. So the idea, how it works, is if you took 83 and divided it by 4. So if I took 83 in my calculator and I divided it by 4, I end up getting 20.75. Well, if I take each of these exponents and divide them by 4, because there's 4 possibilities, there's 0.25, 0.5, 0.75, and then the whole number, 1. Well, we just got 20.75, which means that in the cycle, this is going to be equal to negative I. And if I took, let's say, 40 and divided it by 4, I'd get 10, which is a whole number. So this means I to the 40 would be equal to positive 1. So for exercise 7, they want us to figure out and simplify what each of these are. Well, I want to go through and figure out what all the powers of I are. So if I do 5, and then I to the 16th, so 16 divided by 4 is a whole number, that's going to be 1. And then I have 3, and the 23rd power, if I divide 23 by 4, I get 0.75. So that's going to be negative I. And then the 26th power, if I divide it, I get a 0.5, which would be negative 1. So I have 5 minus 3i minus 1. So in this case, if I combine like terms, 5 minus 1, I get 4, which ends up being choice 2. So if you're looking at those powers, look back at this chart for exercise 5 and the pattern I talked about. Also, again, you'll see that I combined the 5 and the negative 1 together. I couldn't combine the negative 3i because the I is similar to a variable, and that wouldn't be a like term if I combined that.